Welcome to this lesson. In this lesson, we are going to go ahead and see how we can use the distance formula to classify triangles. So we're going to apply stuff from last unit, the distance formula, to some of the new stuff like classifying triangles that we've been learning in this unit. So let's go ahead and see how we do this. So I want you to go ahead and classify triangle ABC by its sides, and they give you some vertices. So first, let's remind ourselves what it means to classify a triangle by its sides. It can either be equilateral, meaning all the sides are the same. It can be isosceles, so two congruent sides, or it could be scalene, where none of the sides are congruent. So if we have to talk about triangle ABC, let's go ahead and start with a rough sketch. I'm going to plot the point A at 1, 1. So there's point A at 1, 1. Then I'm going to plot point B at 5, 4. So here is B at 5, 4. And then I'm going to plot point C at 0, 4. So here is the triangle I'm talking about. So I'm going to go ahead and use the distance formula to find the length of each side. So I am first going to start with length of CA. Remember, the distance formula is the square root of x2 minus x1 squared plus y2 minus y1 squared. So plugging in these values, if I want to find the distance CA, I'm going to go ahead and take 1 minus 0 and square it, plus 1 minus 4 and square it. So I get the square root. Well, 1 minus 0 is 1, squared is 1, plus 1 minus 4 is negative 3 squared, which means 1 squared is 1, plus 3 squared is 9, so I get the square root of 10. So side AC is the square root of 10. Now I'm going to go ahead and find the distance of CB. Well, I could use the distance formula for CB, but they're on a horizontal line. So really, there's no reason to. If I look at CB, it's at 0, 4, and the other one's at 5, 4, so I know that they are a distance of 5 away. So I know that length up there is 5, which means the last one I need to find is AB. So I'm going to use the distance formula to find AB. So I'm going to take 1 minus 5 and square it, plus 1 minus 4 and square it, which means I have the square root. Well, 1 minus 5 is negative 4 squared, plus 1 minus 4 is negative 3 squared, which means I have the square root. Well, negative 4 squared would be 16, and negative 3 squared is 9. So this gives me the square root of 25, and we know that's a perfect square. So the square root of 25 is 5, which means that distance is 5. So by using the distance formula, I know that the sides of the triangle are 5, 5, and the square root of 10. So since two sides are congruent, I know that this is an isosceles triangle. All right. I want you guys to try this one. I want you to classify the triangle ABC by its sides. Given A is 1, 1, B is 3, 1, and C is 3, 4. So pause the video, try it, and when you're done, come back and we'll see how you did. Welcome back. Let's go ahead and see how you did. I'm going to first draw a little rough sketch of this. So A is at 1, 1. There's A. B is at 3, 1. And C is at 3, 4. Oops, I did not plot B right. Hold on. B was at 3, 1. There we go. And C was at 3, 4. So here's A, here's B, and here's C. Well, I'm first going to find the length of AB. And if I look at AB, they're both on the horizontal line when y is 1. And so I can tell that the difference between those 2 points is 2. So I know the length of AB is 2. Well, I can Do the same for CB. Looking at CB, they're both on the vertical line when x is 3. This point's at 1. This point up here is at 4, which means I know that's going to be 3. So now I need to go ahead and find the distance between A and C. So A and C is going to be the square root of 1 minus 3 squared plus 1 minus 4 squared. So the square root, 1 minus 3 is negative 2 squared, plus 1 minus 4 is negative 3 squared. Well, negative 2 squared is 4, plus negative 3 squared is 9, so 4 plus 9 is the square root of 13. So this distance over here is the square root of 13. So the sides of my triangle are square root of 13, 3, and 2. None of the sides are the same, which means that this is a scalene triangle. So there you have it. We have learned how to use the distance formula in order to classify triangles by their side lengths. Good luck with the rest of this lesson.